which is not an example of a Bernoulli trial. Ready? Test a randomly selected circuit to see if it is defective. Is that a Bernoulli trial? That's a Bernoulli trial because it's defective or not defective. So that's Bernoulli. So that's not the answer because it says which is not an example. Did a mosquito die after the area was sprayed with insecticide? That's Bernoulli. Either it died or it didn't die, right? Mm-hmm. Determine if there was flooding last month in Laguna Beach. Is there flooding in Laguna Beach? Yes or no?
Yes.
So Bernoulli. Determine if a doctor in neurology graduated in the top 10% of his class. Either he did or he didn't, right? So that's Bernoulli. Determine how many students cheated on the 40-question final.
Oh, no.
How many? Not did they cheat or not. How many? So that one is binomial, not Bernoulli. Get it? Determine how many students cheated. How many, not determine if the person cheated or not. That's different. So how many is binomial. Whether yes or no is Bernoulli. Okay. The next one is a hypothesis test. Let's do it. The lifetime of a certain brand of heat pump is known to be normally distributed. Okay, X is normal. A sample of 6 heat pumps yielded the following observations: 2.0, 1.3, 6.0, 1.9, 5.1, and 4.6. At the significance level alpha equals 0.10, we will see if there's reason to believe that the mean life of the heat pumps is different from 2.1. Is mu equal to 2.1 or HA mu not equal to 2.1? Find the appropriate confidence interval for the true mean life of heat pumps. Okay, find confidence interval. The sample standard deviation is given. S is given. I don't even know why they bothered to give you S, because they gave you the data, right? 1, 2, 3, 4, 5, 6, N equals 6 data points. The sample standard deviation, it says is equal to whatever, but I changed my numbers. So let's go. How do we do this problem?
They didn't even need to give us the data points.
They didn't need to give you the data points. Did they give you X bar though? You would need X bar for the standard for the confidence interval, and they didn't give you X bar. Okay, so how would you find the confidence interval? They also didn't give you any alpha.
You wrote alpha.
You wrote alpha. 0.1.
Oh yeah, they gave you alpha.
Yeah.
At the significance level, alpha equals 0.10, right? Okay, so 90% CI then, right? So calculator, it's a calculator problem, right? Stat, test, T interval.
Data, right?
And then, yeah, pick data. And then you must have put this into a L1. And it's going to say what list? You're going to say L1, frequency 1. And then it should spit it out for you. What do you get? Go again.
1.8518.
Okay.
And 5.114.
Okay. So I have my confidence interval. Then it says find the test statistic. So now you're going to go stat, test, t-test, right? Find the test statistic. So stat, test, t-test. Two-sided. Two-sided because the fact that you did a confidence interval means it's two-sided, right?
It's always
And also it said, at the significance level 0.10, we would like to see if there's reason to believe that the mean life is different from 2.1. So two-sided. Okay, so what do you have for T naught? 1.7? Okay. That was the next question, right? Find the test statistic. Then the next one says find the critical values. So I have a two-sided test. The total alpha is 10%, so 0.05 here and 0.05 here. T with 5 degrees of freedom. So can we go to 5 degrees of freedom and 0.05?
2.015.
Yep. And minus 2.015. So the question said find the critical values. So those would be them. Critical value and critical value. Approximate the p-value for this test. So here's 1.708 right here. And it wants the p-value. So you want this area times 2. So p-value equals 2 times TCDF. Left 1.708, right infinity, mu, no mu, it's a T, so degrees of freedom 5. Or you can do nothing and just read it off your t-test, right? Or read off your t-test. Next one says, what is the final conclusion? Final conclusion is do not reject, because look where I fell, right?
Professor,
Yeah,
how did you get 1.708?
someone told it to me. Why, is it wrong?
No, I'm just asking.
So I did stat test, t-test, supposedly. Did you guys give me the wrong number?
For what?
This one.
No, that's right. I got that.
Okay, so this is a trick question right here. What is the final conclusion at alpha equals 0.10? And it says conclude that mu is less than 2.1, mu is greater than 2.1, reject mu equals 2.1, do not reject mu equals 2.1, or none of the above. So you want to be careful because look where you landed, right? Do not reject H naught, which says mu is equal to 2.1. That's your final conclusion. I say it's a trick question because had you fallen here, suppose you had fallen in here, your final conclusion would not have been reject H naught. That's not the final conclusion. That's wrong. The final conclusion is conclude that mu is greater than 2.1 if T naught falls in the right rejection region. Are you getting me? It didn't happen here, but I'm saying had it fallen here, the final conclusion would be mu greater than 2.1, not plain old rejected.
Why did you multiply by 2 for the p-value?
Because it's a two-sided test.
Okay.
So the total p-value has to be the sum of this and the same region on the left side.
Oh. And how did you know it was greater than 2.1?
Because it fell in the right rejection region. So suppose I had a number like 2.26 or something like that, where this is 2.015. Then this would be the conclusion. And if I got a number like -3, then I would conclude that mu is less than 2.1. Follow me? Okay, let's see what else is on. This is more confidence interval. I want to pick something different and something new, right? Okay, this one. For quality control purposes, the manufacturer wishes to estimate the mean to within E equals 0.015 of the true value with the 80% confidence interval. What sample size? Find the sample size. Use standard deviation equals 0.1. Okay, let's go. 80% confidence. So let's go to 80. That means 0.1 and 0.1. Anytime they ask you to find the sample size, you're going to pick up the Z number. So let's go to 0.1 column all the way down. 0.1. Right. 1.282 and minus 1.282. So E equals 1.282 S 0.1 over rad n. And E was given 0.015. So cross multiply and solve. So 0.015 rad n is equal to 0.1282. Divide by 0.015. Rad n is equal to, what is it? 0.1282 divided by 0.015. Who's doing it? Anyone?
Wait, why is it 0.1282?
Because I multiplied by 0.1.
Oh, okay.
So what do you get? What do you get?
8.54.
8.54, but then I have to square it, right?
73.04 or 05.
Round up to 74. Okay, next one. The marks on a statistics test are normal with a mean of 62 and a variance of 225. If the instructor wishes to assign B's or higher to the top 20% of the students in this class, what mark is required to get a B or higher? Top 20. So I say we just go to the T table and look up 20. That gives you what, 0.824? Yeah? So 0.824 to x minus mu over 15. 842, thanks. 842. And then solve. So 0.842 times 15 plus 62 equals x. That's one way to do this. Or inverse norm 0.8 comma mu comma sigma. Percentile comma mu comma sigma. Then you don't have to do much. Oh, this is a good one. Let's do this next one. It says the marks, I did that one. We want to test H naught, mu equals 4.4 versus HA, mu not equal to 4.4 at the 5% significance level. The 95% confidence interval for mu calculated from a given random sample is 1.3, comma 3.4.